we'll get into it here. So this is going to be a kind of a talk a lot about ML platform and AI infrastructure from the opposite perspective. It's not really about the practitioner side at all. This is very much deeply about internal platform and supporting Spotify and kind of our needs here. And so just a bit about Spotify. You know what we do, so hopefully a lot of you use it or like it or enjoy it. We've been doing it for a long time. We're coming up on our 20th anniversary next year, which is really exciting as a company. But yeah, Spotify is 600 million monthly active users, like 250 million paid subscribers, which is one of the largest paid streaming companies in the entire world. We're in like pretty much every market that exists around the world, and that presents a lot of fun machine learning challenges. But I want to talk more about the tech and talk about kind of our growth internally within Spotify, how we build and deploy ML, and our growth, especially in the most recent 5 years. So yeah, so let me talk about kind of the Spotify culture here. And this is what we call the golden paths. And I've been at Spotify for about 4 years now, coming up on 4 years now. And it was really interesting when I walked in the door that we have a strong idea about how we build it. So, at Spotify, this is from a public blog post, we aim to create great ways for developers to work and to build stuff at Spotify. One of our hard challenges is to unify all the different ways that we use our infrastructure and provide tools that make sense for our many squads. And this does two things, is that one, you have a very, very supported and descriptive way to ship something. So we have these for data science, for data pipelines, for backend services, front-end services, mobile clients, and ML. And our role within Spotify as ML platform is to build, maintain, and be the spiritual shepherd for this, right? So we kind of watch out and look at industry trends and see how it happens, right? We actually started a little bit before this in ML platform. I believe it was like 2018, 19 is when we started. But in 2020, we had our first iteration of the golden path. And what was this? This is Spotify and Google. We have a really tight partnership. We're a huge GCP collaborator, and a lot of friendly faces here from Google that we work with quite closely. But yeah. What we did is, we built Spotify Kubeflow, which is built upon Kubeflow, TensorFlow extended, which we call SKF, and GCP AI platform for the actual core distributed training. And there's a bunch of different parts in here. It's a little bit hard in the text, but there's things like feature transformations, model analysis, data validation that all became packaged within the TensorFlow extended ecosystem, which Google brought to the table. And as the name implies, this was very TensorFlow specific. An example of this at the core is like TensorFlow records were at like all the data formats. And so everything was kind of bound to this TensorFlow ecosystem following the golden path ethos, right? So it was great. Teams could ship really, really fast, and we really decreased the time to deployment. We were able to scale to our hundreds of millions of people across the globe very quickly. Teams can share and collaborate and contribute to each other's code bases and ask questions about the weird TensorFlow issue or some bugs. And it was very successful. And we really focus on shipping things to production. So taking that idea and moving it out into the world and iterating on it as we go. So digging a bit deeper here, I'm going to kind of zoom by this slide, but there's a few parts here that you'll see. We have Jukebox, which is our feature system, Salem for storing, ML Home is like the experimentation UI, Kubeflow is in this middle, and this is the iteration process as we go. And you'll see how Ray fits into this, and we're going to get into that in a second. So one thing I mentioned, as the spiritual shepherd of ML at Spotify, you have to kind of look around and kind of see a lot of the different trends. And we had a lot of successes in 2021. Where if you look on the left side here, we have like 20% of the squads at Spotify build and use on our golden infrastructure, and that was growing really well. We really liked that. We also saw squads who do ML at Spotify growing 30% year over year, so that trend has increased. But one kind of line that really caught our eye was the research scientists, right? 3% of them at Spotify were using our ML infrastructure at the time. So if they weren't using us, they were doing other things in Google Cloud, which is totally fine. We don't mind that. If you want to use other stuff, that's fine. But if they have a question, they have to ask Google, not us. And we can't help their kind of scaling needs and stuff like that. And they were growing 10%, right? And this is then the first key step that we saw within the company, where like, oh, there was relatively kind of flat, maybe linear, but it really took a step change in 2021. And we saw this 10% number of growth, and that's actually continued to grow. So it's like, okay, this research scientist group is growing within Spotify. They're trying to deliver experiences, and we're not serving them. So we had to kind of look internally and start figuring out what should we do here. In 2022, we partnered with a group within the Spotify tech research team to support graph neural networks that they were building for content recommendations. And in, I guess, one sentence, they were trying to optimize for long tail of content. So neural networks are really good at fitting patterns of what you currently see. But when you have a lot of long tail content, the graph neural network algorithm would have, this is a question of the time, be something that could really help improve a lot of like the really good long tail content that we had. So Keshi Dai, one of our staff engineers on ML platform, and Praveen, who was in the research, kind of partnered together and started to think about this problem, about how we can support them, especially they needed a lot of GPUs, it needed to be much larger. And very firstly, they found that TensorFlow wasn't the right fit, so that kind of ruled out our previous Kubeflow and TensorFlow stack pretty much out of the gate. And PyTorch was a technology of choice, which at the time, I think we were probably late adopters on this trend. But we had such a strong core of TensorFlow, and it was working for us, we didn't really have to do it. But now we started to see all this research science and people trying to build on PyTorch. We're like, okay, we need to do this. And this is when they discovered Ray. So Ray entered the scene kind of early 2022 as something that we were helping support the research and tech scientists. So they helping them with their infrastructure, they would build on top of us. And this kind of expanded us in 2 dimensions, and I think this is a really fun graph that we put together to talk about kind of like where we were previously. So, very like, the left side here and the current, we were very focused on, the ML engineers with TFX, right? And we really zoomed out to really support research scientists, data scientists who are these like kind of quasi-modelers who want to use ML in their, just metrics and stuff like that. And yeah, so we kind of expanded that box to support who we're covering, and Ray was really kind of one of the cornerstones to help enable that, right? It really provides a lot of great SDK and tooling for many frameworks that enables people to be super productive. And so in 2023, we launched our first iteration of Spotify Ray, and this is another public blog post. But really the theme here is that like gone are the days when ML was the domain of a small group of researchers, and we want to democratize that effort as large as we can. We also saw researchers doing more ML stuff. We saw MLEs doing more research stuff, and things are kind of shifting. We have this term internally called T-shaped engineers, and that definitely shown through to the ML domain as well. So what did we build? We built this kind of shared infrastructure, SDK, services, and tooling that allowed people to build and play with on top of Ray. So this is a little code example here. SP Ray, you create your cluster with a bunch of different arguments. One thing there is GPUs per worker, so that you can give them access to GPUs really quick. And this was a real step change for them, right? So before they had to figure out their own cluster, set up GKE, understand all this stuff. So we just did one kind of pip install, boom, done. Then they can get access to their servers, the Ray dashboard, VS Code, and allow them to develop and iterate interactively. And this was kind of like this first kind of researcher-based offering built on top of Ray. And it really caught on pretty quickly and started to get kind of this really deep traction within the company. People liked it for a few reasons. I'd say primarily and most importantly, it's around DevX and just like ease of use and interaction. So like if you give people a tool within a company, it has to be really easy for them to interact with, right? And like, your documentation is not going to be as good as open source because you only have 25 people writing documentation versus 25 or 1,000 people who are contributed to Ray, right? So you're going to be a natural disadvantage in a lot of ways, but if you make it really nice, really well supported, and focus on just like getting it into their hands in a very easily and consumable fashion, it works out well. And 2 is easy access to GPUs. So GPUs, they've talked about it a lot, have been really important, and still just kind of like creating a GCE VM or like a VM with a GPU attached is just a lot for somebody who's not really infra savvy to do, and a researcher who's really good at the algorithms doesn't quite just like, might not make that leap or have a struggle through it, right? So kind of giving them a way that they can just kind of boot it up and go really kind of made them hyper productive. So this is when we launched Hendrix, which is our like full platform, which has like all sorts of things from workflows to the core distributed compute, and kind of the underpinning here in the first real product we brought to, we called like GA, was the distributed compute product, Hendrix Compute, built on Ray. And that's kind of underpinning that we did. And we started this journey in about 2023. And here's a rough diagram of our current ecosystem. It hasn't really changed since about 2024. But we have our features stack. We have our workflow stack, which kind of manages the production workflows and orchestration, model serving, all under this compute. We have Backstage, which is our developer portal, and a very strong presence there. So you can see your experimentation tracking and stuff like that all within Backstage. We have our SDK that people can use and integrate with on their code side. This is all on top of the Spotify core infrastructure. So we have our data ecosystems, our compute ecosystems, and our orchestration ecosystems. And I'll kind of get to some of the nuances and intricacies there. And one piece I do want to call out is this piece called Workbench. This is also a part built on Ray and our compute cluster. And this is our effectively collab or VS our notebooky ecosystem that people can do within the browser to just one click create a cluster and go. And this is something that people have really requested and needed and is this interactive side versus the production side that we focused on in 2021. So I'm going to talk about kind of 3 bumps to production that we encountered along the way and kind of share how we do it and kind of what we do. And this is going to be pretty code-oriented and infra-oriented, but yeah, interactive workloads and kind of how we manage that. Integration with Flight, which is our orchestration tool, and how we've kind of handled that. And also feature preprocessors for online inference is a big bump we've ran into along the way. A lot of this has been done in partnership with Anyscale, and they've been super helpful for us along the way. And so I'll talk more about that in a second. But interactive workloads. So I think this is kind of the biggest paradigm shift for us as we talk about AI and ML platform and what we do. So our primary, 2021, our tenet was let's get people to production, right? And that was all about scheduled workloads, automated retraining, these really production-oriented things. And so the clusters come up, they come down. It's pretty manageable. Interactive workloads have a much different mechanism, right? Number one, they come up and stay up, right? And if people can log off at a day and they'll come back the next day and they want the same things come in. They may not have a job running on there, but they may have code on there, data, artifacts, whatever. So it's just a different lifetime mechanism. It's something you have to kind of be cognizant about. Secondly, which is something on the picture here, that the user has to go actually into the cluster. And this is just something that just, as an infra team, you have to be cognizant about and have to actually manage just how people get into these things, right? Previously in SKF world, we were on this GCP Vertex AI platform, which is this managed service for a lot of training, and now we're actually running these clusters in-house. we do all our stuff in one zone, Europe West 4. We have these, two big GKE clusters. And just like kind of a few things that we do are, we have to address multi-tenancy concerns. So we've learned this past in our Kubeflow days, but we have to also manage noisy neighbors internally, resource contention internally, and also just like GPU reservations, like all this kind of stuff that you just have to, you're basically like a mini cloud provider, right? So we have a lot of similar type of things that we have to do in terms of like namespaces so people can request their resources and then give them back and stuff like that. Not going to dive too much more into that, but we also have node pools per each VM and GPU type. So we have like 16 different node pools now, and it's kind of growing pretty much, but it has the GPU, A100, GPU, A100, 4 of them, and then the spot instances. So all these kind of node pools allow people to pluck from them and then give them back, and we can have this kind of little mini ecosystem of for the interactive workloads. Cool. So Ray cluster versus Ray job. So we are a real heavy user of KubeRay project, which is the Kubernetes operator for Ray, and that's what kind of manages all of our stuff. And that's been led by the Ray team, and we've contributed pretty heavily to it along our life. But kind of going left to right here, and I'm not going to go read through all the bullets, but you can hopefully watch the video in the end. But the users kind of submit they create their configuration and submit it to a managed service. And we have a Ray cluster if they want to do interactive stuff that actually creates the cluster and leaves it up for them. And they can submit jobs to it. They can use the dashboards and do all their stuff. And kind of just like we do all the integrations with the rest of the Spotify ecosystem. And it's this kind of this long-lived cluster that they can have and use. And then we use Ray job for the actual batch training use cases for production. And the Ray job, what it does is it creates the cluster and then deletes it after it's done. And this handles the life cycle, so there's no orphan stuff, and that we don't have to put the burden onto the user to clean up their resources. So when they submit a Ray job, they basically say, here's the amount of resources we want, and then submits it to our service, then run. And they can have their batch needs. And the Ray job also supports a lot of advanced customization. And so basically kind of we see two different kind of types of users who are doing this. The Ray clusters are the kind of more standard researchers who are just trying to like experiment with stuff and do stuff. And then there's this like power user practitioner, and they'll kind of always jump to the Ray job straight out of the gate. They may like have custom images or some like novel thing they're trying to do. And so we kind of give them access to this, go kind of one step underneath and go directly there. And this paradigm's worked really, really, really well for kind of managing these two different types of usage loads and enabling them to deliver. The next one I'll talk about flight. So, again, kind of looking back to our golden path ethos and what it is, we have flight as our like orchestration system of choice. And this handles all of our data workloads. So when we talk about an ML project, there's going to be some subset of the group who's going to be a data engineering group that's going to be writing data pipelines for their stuff. And then the next step is the ML training, feature processing, training, eval steps, right? And we want to become close with that so that they don't have to basically have two separate orchestration systems of Flight and Kubeflow. And Flight actually has a lot of built-in stuff for Ray, but the core limitation that we ran into early was that the original Flight Ray integration was that it would basically create a Ray cluster on the Flight cluster. And didn't work for us 2 reasons. One, just company organization, we wanted to manage our own SIP. But more importantly, and I think kind of the interesting part was that we wanted to have our own cluster to support the interactive workloads. So if we only had this like Flight supported stuff, we would lose out on that interactive paradigm and pattern. So we kind of had to have our own cluster here. on the right side. And so basically what happens is, when Spotify Flight kicks off, it'll create a cluster on our service, which then creates one on our actual compute cluster. And we want to propagate that all that stuff back into the original Flight system so that people can see their logs and stuff like that. So here's just kind of like the task that we wrote. And our array job is config v3 is kind of just how we do it. But a few interesting points here is the runtime environment. So this is allowing people to use all the Ray kind of coolness around I think there's also some new stuff around Ray UV in the way they can install plugins and stuff like that. So they can configure the runtime environment there. Specify the service accounts. Create your worker groups, specify your namespace that you're operating in as a user, in your GKE cluster, and then it runs this as a Ray job within our cluster, right? So it'll spin up the cluster, spin it down, and then it pipes all the stuff right back through. So this has really kind of enabled people to develop a lot faster. And kind of one technical point that's I think pretty important and our people have been really helpful is that with this integration, it allows, Flight has this cool paradigm that you can just pass parameters around the DAG and they'll pass through. You also kind of manage storage and putting stuff in storage and then retrieving it in your next step on a different box. You can just kind of manage and pass things through. Yeah, so that Flight integration has kind of really helped and kind of bridged that kind of production gap so that now you have this interactive way of doing things. And now, the production way of doing things on Ray through Flight. PyTorch inference. So this is, I guess, less multi-framework, but pretty specific. But the PyTorch inference performance was a big problem for us. And this kind of, we're pretty high scale. We have a very strict latency requirements for a lot of our use cases. And so we developed an extension of the preprocessor API that allows you to export your Ray preprocessor chain in a series of PyTorch graphs that can be ensembled with your model at serving time. And we kind of took this inspiration from the TensorFlow. So TensorFlow has this thing called TFX has this thing called TensorFlow transform, which then takes their feature transformations, puts into a graph, fuses it with your model graph. And so when you have your inference, it's just one graph execution. The current way within Ray and on serving these things is that you have your transformers that are in Python, so it runs the Python code and then your graph code, and that was wasn't meeting the performance needs that we had. And we've been working a lot with the NYC folks to actually help contribute this back to the community. So it's still a work in progress, but we're getting there. But yeah, long story short, we were able to reduce the latency from 350 milliseconds to 70 milliseconds with this technique. And I'll kind of give you a quick snippet here of what we did. So yeah, we have this cosine similarity feature preprocessor here. You extend from Hendrix preprocessor, and you define two types of transforms here. So you have your pandas transform, and then you have your torch transform, and you define those separately. And the transforms pandas is used during training time, and your torch transform is used during actual the online inference. And then we offer a bunch of testing utilities to actually make sure that those two are equal. So we have asserting that the preprocessors are actually the same, and that you can inspect data sets and stuff like that. So when teams are now writing and shipping production PyTorch Ray code, we have a whole bunch of standard features that we have within our core lib. And then if they want to write their own, they extend from this and implement these two functions, and then they can ship in a performant way that'll meet Spotify scale, which is not just for latency, but also for costs. Yeah, so kind of looking at it today, I got 5 minutes left, so we're good here. Where we are today is we have about 128 active, we call them squads internally, but teams here using our platform, but the workflows is kind of the important one. You'll see Ray, there's a little data issue here, so ignore that kind of drop off. It was actually a little more granular there, but you see Ray here has continued to kind of surpass, and I think like last month we crossed the SKF graph, and we're seeing that kind of continue to grow, and we're going to continue to kind of invest in the this kind of multi-framework Ray world in this interactive compute paradigm in addition to the production compute paradigm. Yeah, this is kind of just a fun vanity metric. You can see that teams are using compute clusters and using a lot per week. Yeah, so there's still some open questions that we have that we're working with Anyscale and Google to improve as Ray matures within Spotify. But the biggest one is the scalability of the feature preprocessors and with some of the gaps between the TFX ecosystem. And in particular, I want to talk about the data validation. So one of the important parts within the ML processing or ML workflow is that ML engineers and researchers want to see their data see their metrics and statistics of their feature sets that they're working on. And if they are very large, you can't do them in Ray because it does a full pass of the whole data set. It doesn't quite use the MapReduce type style where you can kind of chunk it. And so you basically have to grow your cluster to have it foot in full memory. It's not feasible for some use cases. So we're working with them on this the aggregation V2 parts within Ray to then enable these types of things. And that'll be the core data validation and the data validation, some of these metrics parts of it. The other kind of part, which is also paired here, is we have the accelerator management. So this is just standard GPU access stuff and being able to have reliability. So if there's no spot instances, they can fall back to regular instances and stuff like that, and cost managements that go with it. But additionally, we're striving for better observability. As Robert mentioned, if you looked at remember his graph with PyTorch, Ray, Kubernetes, that's exactly what we do. So I was like, oh, that looks familiar. But kind of bringing the Ray and the Kubernetes stack together and having them be aware of each other, there's a lot of things that they don't have connections of and awareness of now that when you bring them together, it just helps the practitioners be a lot more effective at debugging their own issues and stuff like that. So we're working with the GKE team on Google and Ray to kind of just help bring those things together so they can be kind of more aware of just of each other, so that they can people can develop and be a lot more productive. So yeah, before I say thank you to you all, I do want to say thank you to the ML platform team. This is a terrible photo we took during our core week. But we're a pretty small team of 20 or so engineers, and we've had 60 contributors to our total ML platform from across the company. Pretty proud of that, and they've done the hard work. I just kind of help support them. Some of them are here. You can ask us questions afterwards. Yeah, just want to say thank you. I left that bottom line there by accident, but yeah, happy to chat and kind of share our journey as we've kind of helped these teams distribute applications at Spotify, and thank you.